Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called maximum sum of almost unique subarray. We were given an integer array nums and two positive integers m and k. Return the maximum sum out of all almost unique subarrays of length k of nums. Okay, this is complicated. If no such subarray exists, return 0. And a subarray of nums is almost unique if it contains at least m distinct elements. Okay, so here's the m. And a subarray is a continuous num. Okay, so this is the definition of subarray, so we don't have to read this one. We just have to know it's a contiguous non-empty sequence, okay, of this nums array. And so a subarray must have at least m distinct elements. And we're going to return the maximum sum of this subarray at most size k. Okay, return the maximum all almost unique subarrays of length k. So this length is fixed. Okay, so this combination of subarray and a fixed length immediately reminds us of a sliding window. Okay, let's take a look. So here's example 1. We have this array and m is 3, k equals to 4. So let's see if we have this subarray, k is equal to 4, okay. And is it almost unique? Yes, it is, because it contains 4 elements larger than 3, okay. So this could be a potential answer. So let's add them together. This 13 is 18, okay. So this could be a potential answer, okay. And let's move forward. This one, it also contains 4 elements, which is larger than m, so it's almost unique, and the window size is 4, okay. So this is also a potential right answer. And after adding them together, we got 17, which is less than the previous subarray. So the current maximum is still this subarray. Okay, and let's take a look at the next one. So we have 3 distinct elements, which is, it says at least m, so which is valid. And the window size is 4, which is also valid. And now we can add them together. So that's still 18. Okay, so after calculating, either one will do, but we don't really care the subarray. Okay, we don't care about it. We just care what the maximum of the sum of all the elements in the subarray is. So we should return 18. Okay, and here this one should also be the same. And let's take a look at this one. So this subarray, we see there's only 2 elements here, okay, but m is 3, so there should not be any subarray that will return the correct output. So we should return 0 in this case. Okay, so now we know we have to use a sliding window, but there's a variation here, that is this m. So we have to track how many distinct elements we have right now. So for that, I think we should use a map to record the element and its frequency. Okay, so let's set up everything here. And we should also need a current sum, which is equal to 0. Oh, okay, so this is long, so I suppose let's take a look at the constraints. Oh, okay, yeah, so it could be very big. All right, so we shouldn't use int, instead we should use long. Okay, and we should also record a max sum, which is equal to 0. Okay, and now we're going to set up that map. Okay, the element. So it should be the element itself, and the frequency of it. Okay. So, but I think for this one, it could probably be better if we just, yeah, we can put it like this, but if needed, we can change it to long because I think we might encounter something like that. Okay, but we'll see. Okay, so let's see. Let's call it frequency map. So like freak, and so it's going to be a new hash map, and we should initialize our sliding window. And it shouldn't go beyond the length of the nums. Okay, so it's a list. And okay, increment it. Okay, so what should we do in the sliding window? Okay. Let's take a look at the first one. 3, 1, 7. Okay, so we have left over here, right over here. So every time we encounter something, a new element, we should first like add it to our current sum and put it into our frequency map. Okay, so we do this and we move to the next element. Once R reaches to K, like here, we should consider moving L. Okay, so let's do the first things first. Okay, so a current element equals to nums dot get rate. Okay, so every time we see it, we put it into the frequency map per element. So if there's nothing, get our default. Okay, and then we should add it to our current sum. Okay, current element. Okay, perfect. So next we should check if the window size is larger than K. Okay, so if it ever happens, we should use while. So right minus left plus 1 is larger than K. If this happens, we should shrink from the left. Okay, so we will have this left element, nums.get left. Okay, so what should we do is to remove it from the frequency map. Okay, so left element freq.get left element and -1. Okay, so sorry there are so many typos because I recently changed a new keyboard, so I'm still familiarizing myself with it. All right, so the frequency map should remove the left element. Okay, so and we should remove it completely from the map if there's no more. Okay, so if frequency dot get left element equals to 0, we should remove it. Okay, after that we should remember to subtract it from the current sum and increment the left pointer. Okay, so now this part guarantees that we have a valid window size of K and at least m distinct elements here. Okay, within this array. So now we can do the comparison. So if we have at least m elements. Okay, so it's going to be larger than or equal to m. We are guaranteed we have this k-sized window. We are guaranteed we have at least m elements. Okay, so we can calculate max sum equals to max sum cur sum. Okay, and max sum should be initialized to 0 because if nothing happens, we should return 0. Okay, so at last we should return max sum. Okay, so this should work ideally. Yeah, it looks good to me. So let's calculate the complexity of this. So since it's a sliding window, the time complexity should be O(n), of course. And the space complexity, I think we only have a map. And at most, it will contain k distinct characters because the maximum size of this window is k. Okay, let's see. Okay, looks like it passes all the test cases. Thank you so much for watching. I will see you in our next video. If you like the video, please like and subscribe to my channel. See you.